Bismillahirrahmanirrahim. This is lecture number 10. First order circuits responding to exponentials. So far we have studied about differential equation that was equals to 0 or that was equals to some constant. Now here we have a function of time and the function is exponential. So first of all we have drawn a Thevenin equivalent of RC circuits, series RC circuit, such that V of t is into U of t. Now this Vt in source voltage that is equals to Va e raised to power minus alpha t. This is a function. Here you can see that Va is a maximum voltage or and this is exponential having a function of time with this alpha. This is a damping constant. So if we write the differential equation of it, so we have R Thevenin, this is R Thevenin, times C dV of dt, as the voltage across this capacitor is V. So dV t plus voltage is equals to Vt, that is a function of time. Vt is a source voltage, this Vt. Now again, as what we have done before, we will separate the natural response and the forced response. So we have this equation, Vt, this will be equals to Vn of t, mean natural response, plus Vf of t. First of all, we will evaluate the natural response, Vn of t. This was equals to k e raised to power minus t over tau. And you already know that this tau was equals to R Thevenin times capacitance. So we will evaluate this k constant after forced Vf of t. This is equals to kf e raised to power minus alpha t. As we already know that the derivative of exponential is again exponential. So its function or its solution will be kf into e raised to power minus alpha t, and we will find out the value of kf. And kf is the constant. So we will replace this force response and natural response to this differential equation. So we get R Thevenin times C into d by dt of Vf plus Vf is equals to Vt of t. This is a force response equation. So we have evaluated this Vf t, this form, and we will replace here. So we get Rc of Rt, R Thevenin in times constant, into d by dt of kf e raised to power minus alpha t plus kf e raised to power minus alpha t is equals to V of t. And this Vt is equals to, as we already know from this equation, this is equals to Va e raised to power minus alpha t. This derivation is a little bit tedious, but after we will do this complete derivation, I'll tell you some shortcuts to understand and memorize this type of equations. So these are some constants, and this will come out from the derivative. So we are left with R Thevenin times C into Kf multiplied by minus alpha into e raised to power minus alpha t plus this Kf e raised to power minus alpha t is equals to Va e raised to power minus alpha t. As you can see that this e raised to power minus alpha t, this e raised to power minus alpha t, and this e raised to power minus alpha t, this is including in every term of the expression, so we can cancel it out. So we are left with R Thevenin times C into Kf and minus alpha plus Kf is equals to Va. So here our Kf will becomes equals to Va over 1 minus alpha R Thevenin times C. So this is a constant Kf evaluation. Now we have this natural response and we have this forced response, and now you can substitute in this equation. So we get V of t, this will be equals to Vn of t plus Vf of t, forced response plus natural response, and this is equals to this one you have already calculated in your previous lectures. This was equals to k e raised to power minus t over tau, and here tau is equals to Rc plus Vf is equals to Kf, and this is equals to Va divided by 1 minus alpha times R Thevenin times C, and exponential is here minus alpha t. So by applying its initial conditions, so at time t is equals to 0, we have V at 0. This will be equals to your V naught, mean initially charged voltage, mean if your capacitor was already charged or not, and k e raised to power 0 plus Va over 1 minus alpha times R Thevenin times C, and again e raised to power 0. So this was for natural response and this was for forced response. So we get V naught is equals to K plus VA over 1 minus alpha R Thevenin times constant C. Now we will simplify some more, and we get the value of K here. So K is equals to V naught minus VA over 1 minus alpha times R Thevenin times C. So our final solution or final equation that will become in the form of V of t, this is equals to V naught minus VA over 1 minus alpha R Thevenin times C, and exponential is minus t over RC plus VA over 1 minus alpha R Thevenin times C multiplied by e raised to power minus alpha t for t greater than or equals to 0. So what conclusion we drive here? The voltage across the capacitor is the sum of two decaying functions. Here you can see that there are two time constants. One is t1 and this one is equals to R Thevenin times C, and you have this second time constant and this is equals to 1 over alpha. In this lecture, you have just seen the derivation of the solution of our differential equation which was equal to exponential constant. In coming lecture, I will try to explain how we can memorize this long equation, which is equals to V naught minus V over 1 minus alpha RC R Thevenin times C e raised to power minus C over RC. This, if you solve numericals one or two times, you will understand this equation or you will memorize it. But there is a very easy way to memorize this. I'll tell you in next lecture. Thank you very much.